Okay, so I'm going to start with the guided task. This is the one that I'm not so sure on. Um, so it asks, are the data distributed, um, normally distributed? So I didn't really know how to be able to tell that on just doing like the ANOVA test. So I kind of did this, and I still don't understand how to read this. I would think that if it was significant, it would show normality. But honestly, I really don't understand this. I don't even know if I'm doing the right thing. Um, but there's no extremes in the stem and leaf plots. This, I don't know. I think this looks pretty normal. Um, there's about as many on one side as there is the other. Uh, see, there's 3 and 3. That's a little different. These aren't smashed like pancakes, so I'm just assuming that the data is normal. Let me go back up here. I don't, like I said, I don't know if I did that right. Um, I did it twice because, I just wasn't sure. Not doing it right. So then I ran the ANOVA test on it. I have this information, this information. Um, So the next question was, based on the error bar chart, which groups, if any, do you think are significantly different than the others? But just by looking at it, the exam looks different. It looks like it has a lot more higher um, darts, basically. Was the assumption of homogeneity of variance met? So whenever we were in class, professor said that if it's significant, then that means there is no homogeneity of variance. And if it isn't significant, then there is homogeneity of variance, which kind of confuses me, but I'll just go with it, which means that, hold on, I just got to do this, um, there isn't, that there is homogeneity of variance, which means we're going to work with the Bonferroni. So the assumption has been met. And if it wasn't met, then we would use the Gaines Howell comparison. And I've already brought that down and made it smaller. But then I'm also curious about when we're supposed to use these robust tests of equality means. If whenever, when we would use this. Because I thought if we don't um, meet the assumption of homogeneity, we would use these. So now I'm just a little bit more confused. But yeah. And there was significant relation in the exam and the workshop with P equaling 0.048. As long as you don't round up, you're fine. Between lecture and workshop had 1.0 as a P value, and lecture and exam was 0.064, and the last two had no significant relation. And another question was, what does the F value represent? The F is a ratio of two variances or two mean squares, which today in class I learned is between over within, which equals F, and F equals T squared, basically. So it showed that this was significant. Um, and what is it? What does it all mean? It means that basically this right here is the effect, and there is a moderate effect of differences between groups. Stats class rugby. Okay, rugby. Well, I guess I'll just run this one again so I can show that I know how to do it. Okay, so your data set, analyze, compare means, one way, ANOVA. You're going to have your dependent variable here, your independent here. Not going to mess with contrast, go to post hoc, and go to Bonferroni Games Howell. And this is supposed to be for graduate school. Press continue. And this is options. You're going to have descriptive homogeneity of variance, and a means plot. Press continue, press OK. Let's see, where did it go? Did it seriously? Okay. It went here, I think. Okay. So here's the descriptives. Just to show that I know how to do this. I'm going to edit this because you want to use based on mean. Use eta squared. Oops. Okay, and then so basically we have to decide whether or not there's homogeneity of variance. In class, we basically said that there was no homogeneity of variance due to. Okay, I actually kind of explained it in this last one that I don't know. It just kind of confused me, but this right here said it was significant. Significant. Therefore, there is no homogeneity of variance. So there is no homogeneity of variance. Therefore, we will not use Bonferroni. We will use the game's HAL. So we'll start off by deleting this. I'm going to just go ahead and delete this because we don't need that. And let's see. Wales and New Zealand is right there. And Japan and New Zealand is up there. Let me see if I know this right. Yep. Okay. So Tonga, New Zealand, Japan. Here, delete. Okay. And that's that. So now we have the mean differences and the significant values. We talked a little bit more. Basically, Tonga is very aggressive. It's very aggressive. I can go back. I'm probably over the time limit. You can totally just stop watching now if you'd like. That's not very quick at getting the point across. Okay. Tonga does cause more injuries than all the other teams. Japan. Okay, so one question was Japan causes fewer injuries than Wales and New Zealand. Japan, Wales, no significant difference. And New Zealand, no significant difference. So yeah. And then Wales and New Zealand inflict similar numbers of injuries.